Why is 3 to the 0 equal to 1 and not 0? Why is x to the 1/2 equal to the square root of x? And how are you even supposed to evaluate x to the 4/5? All these questions. Well, let's start off with the first one. Let's take 3 to the 0 power. The number at the top tells us how many times we should multiply 3 together. And in the case of 0, that's nothing. We should not multiply the base number at all. So, our second fact from there that will help us figure out what a number to the 0 power is the fact that we can always multiply 3 by 1 and it still remains 3. If you multiply by 1 again, it's still 3. And again, it's still 3. So 3 times 1 is equal to 3. And 3 is also equal to 3 to the first power. Therefore, we can say that 3 times 1 is equal to 3 to the first. And as you can see, the number at the top tells us how many times we should multiply 3, and we're multiplying by 3 once with itself. So if we change that 1 to a 0, well, we can just say we don't have to multiply 3 at all, and we get rid of that 3. And all that remains is the 1. So 3 to the 0 power is equal to 1. And it works for any other number as well. We can use the same logic, such as 2 to the 0 or a million to the 0, cross out the 2 and a million, and all that remains is 1. So any number to the 0 power is equal to 1. Another way to figure out what a number to the 0 power is by making sure the addition rule remains true. If we have two numbers with the same base number but different exponents, we can just add the exponents together and it will equal the same thing. In order for that to work for 0, let's take this example here. 2 to the 3rd power times 2 to the 0 power has to equal 2 to the 3 plus 0. Well, if 2 to the 0 is 1, then it all works out because 3 plus 0 is just 3. So, and any number times 1 is the same thing. So 2 to the 3rd is equal to 2 to the 3rd. However, if 2 to the 0 was any other number, it would not work. For example, let's take 0. If 2 to the 0 is equal to 0, then the left side becomes 0, but the right side still remains 2 to the 3rd. And 0 is not equal to 8. So therefore, by the addition rule and some intuition, we can say that any number to the 0 power is equal to 1. We have covered why a number to the 0 power is equal to 1. So what about fractions? Right? What would 2 to the 1/2 equal? Would it equal 1 or would it equal 4? Well, before we begin, let's first remember that every number can be rewritten as a fraction. 4 can be rewritten as 4 divided by 1, which is also equal to 4. Right? Which is also equal to 8 over 2. So, with that fact, let's continue. So 8 over 2, as we know, is equal to 4. We can divide that by 2 again, which is equal to 2. Divide that by 2 again, making another fraction, which is equal to 1. And then we divide by 2 again, and we get 1/2. Right? So all we were doing there was dividing by 2 or multiplying by half. Well, however you want to look at dividing or multiplying by fractions. So now, if we do the same process to the exponent, we can figure out a pattern that will get us eventually to 1/2 or a fraction in the exponent. So say we have 4 to the 8th power, which is equal to 65,536. We multiply 1 by 1/2 or divide by 2, whichever one you think, right? And we get 4 over 4, which is equal to 256. Then from there, we divide the 4 by 2, which is equal to 4 to the 2nd, which is equal to 16. Now we divide the 2 by 2, which is equal to 4 to the 1st, and that's equal to 4. And finally, we divide by the 1 by 2, and we get 4 to the 1/2. And that's our mystery number. Let's write what we just did in descending order to see if we can notice a pattern. Let's first try subtraction. And there isn't really anything that pops out. As you can see, the difference from the first to second is 65,280, second and third is 245, and third and fourth is 12. Nothing too big. Let's try dividing. Well, this is interesting. From the first to second, you divide by 256. Second and third, it's 16. And from the third to the fourth, it's 4. So there is some pattern here. Here comes the amazing part. Since we know there is a pattern, and the pattern is caused by multiplying the exponent by 1/2, if you can figure out what these numbers mean to each other, we can figure out what 4 to the 1/2 is. And that's just beautiful, in my opinion. So let's just focus in on one part of sequence to get a better understanding. We can rewrite 256 divided by 16 to be as 256 is equal to 16 times 16. And 16 times 16 is just 16 squared. And here it is. 16 is also the number we divided 256 by to get to 16 when we divided the exponent by 2 or multiplied by 1/2. So whenever we put a number to the 1/2 power or we're multiplying its exponent to the 1/2, that means we're dividing that number a with the number when squared equals a. Or in other words, a to the 1/2 is equal to the number when multiplied with itself twice equals a. So a to the 1/2 is equal to a number x, and x times x is equal to a. Therefore, each x is the square root of a, and that is why a to the 1/2 is equal to the square root of a. So now we know that 4 to the 1/2 is the number when multiplied itself equals 4. That phrase can be written as a circle squared is equal to 4. In that circle goes the number. And the only number squared that equals 4 is 2. Therefore, 4 to the 1/2 equals 2. And the same logic that we use to find 4 to the 1/2 can be applied to 4 to the 1/3 and 4 to the 1/4. Where 4 to the 1/3 is just x, where x is the number you multiply 3 times to get 4, and 4 to the 1/4 is the number x, where you multiply x 4 times to get to the 4. Well, now what if we had a mixed fraction in the exponent, like 2 to the 4/5? Well, using the addition rule, we can rewrite that as 2 to the 1/5 plus 1/5 plus 1/5 plus 1/5, and that can be rewritten as 2 times 1/5 times 2 to the 1/5 times 2 to the 1/5 times 2 to the 1/5, which is just repeated multiplication. So we can rewrite that as 2 to the 1/5 to the 4th power, since we're repeating 2 to the 1/5 4 times. So 2 to the 4/5 is equal to 2 to the 1/5 to the 4th power. What you saw here was the application of the multiplication rule. The multiplication rule states that you have a number a to the x power to the y power. You can just rewrite that as a to the x to the y, which simplifies things a whole lot. Now, using the multiplication rule, we can separate 2 to the 4/5 into 2 to the 4th times 1/5, which is just equal to 2 to the 4th to the 1/5 power. The inside part becomes 16, and then we can use a calculator to figure out the whole answer equals 1.15. So to recap, we can use the multiplication rule to split it into two different exponents and solve them individually. An important part of multiplication is the commutative property. Therefore, we can use that to our advantage. For example, if you have 4 to the 3/8, we can write that 4 to the 3rd to the 1/8, or 4 to the 1/8 to the 3rd. Those are both equally valid and equal the same answer, and we can use that to our advantage to figure out the easiest way to solve for things. Usually you will write exponential fractions as radicals. So 2 to the 1/2 is the typical radical and then the base number underneath. And for other fractions, it's the radical with the denominator on the outside. And so for mixed fractions, you handle it pretty similarly. You can choose which part goes underneath the radical. For example, if you have 2 to the 4/5, you can write that as 2/4 to the 1/5. To the 4th, since it's on the inside, it's the first exponent, it would go on the inside of the radical. 2 to the 4/5 can also be written as 2 to the 1/5 times 4. So now the radical part goes on the inside, and to the 4th power goes on the outside. That's all I have for you guys today. Remember to write down your work, and thank you for watching.